Hello everyone. In this video, I'm going to discuss some basic principles of counting and permutation and combinations. And I will give a couple of examples in order to show you how these principles or methods work. So suppose a student want to participate in his inauguration, in his commencement ceremony, and in attending this ceremony, so he has uh, two shirts. So suppose he has just two shirts and he has three pants and one shoe. So if in this simple example, if he wants to attend his commencement ceremony, how many ways he can dress himself? This could be the questions. Okay. So let me show you. He has shirts, first shirt, second shirts. He has pants, first, second pant, and third pant. He has shoe. He has just only one shoe. So he can dress himself up in this way, first, second, and third. This is the three ways. This is the fourth ways. This is the fifth ways. This is the sixth ways. So six ways the man can dress himself, dress himself to attend commencement. Okay, to attend graduation ceremony or commencement. So now how we can compute these things for a large scale problem. From this small scale problem, we can get the idea. Two pants times three, two shirts times three pants times one shoe. This is the sixth way we can, the student can dress himself. This is the formula and this is the visualizations. Now, if I want to give you another example, so a man wants to buy a car, and how many ways he can buy a car? Take a look at that. He has a brand. Among this brand, there is a Toyota, okay, and there is a Honda, there is a GMC, there is a BMW, and there is a I, and then I want to also consider here Tesla. Okay. So I put here five brands and then I want to put here color. Color we can put here red, black, yellow, green, and red, black, white. Then I type like type here type is the two-wheel drive or four-wheel drive, right? And then I want also to find it where it is produced, like the manufacturer, okay? Manufacturer. Suppose all these car manufacturers in all of this location, USA, China, Japan, Germany. All of this car is produced in all of this location and then Korea. So now how many ways a person can buy a car? This is the way he can buy a car. This is the way he can buy a car. This is the way he can buy a car. This is the way he can buy a car. This is the way he can buy a car, right? He can buy a car like this way, that way, and this way. So one, two, three, four, five, six. Six type of brands. One, two, three, four, five. Five types of color and two types of drives for two-wheel drive and four-wheel drive and five countries. So that many ways a person can buy a car. So any probability book under graduate or graduate level that starts with this counting principle, it is so basic. So that is why they name it as a basic principles of counting. Later stage, when we saw permutation and combinations problem from different category, when we will multiply, and if you ask a question why we are multiplying, my immediate answer will be basic principles of counting, or basic principles of counting. In short, it is said as BPC, basic principles of counting. Upcoming problems that you will see in permutation and combination as well as probability problem, where different categories of probabilities will be computed, and during that time if you ask a question why I am multiplying, why the problem is solved by multiplication, the answer will be BPC, basic principles of counting. Okay, so that is the end of the very first counting principle. Now I want to discuss about two more counting principle known as the permutations and combinations. Permutation. Okay, so permutations will be used when order matters. Order matters. So for example, suppose there is a three letters A, B, and C. Okay. How many ways the letters could be arranged? How many ways? How many ways the letters of the word cat can be arranged? Can be arranged. Okay, if this is the question, how many ways? Now take a look at the CAT cat, CTA, and then ACT, ATC, and TAC, and TCA. Okay, so six ways. So three letters can be arranged, all the three letters, I'm choosing all three. So this is the formula of 3 and 3 minus 3, which is equal to factorial 3 over factorial 0. Factorial 0 equal to 1, factorial 3 equal to 6. So we have 6 in here. Okay, we have 6 in here. So the permutation formula is this: N P X. N is the total number of element. X is the number of element that we select from N. So the formula is N minus X. This is the formula. And this notation is known as the factorial. What does that mean? That means N means N times N minus 1 times N minus 2 times N minus 3, gradually reducing up until 3 times 2 times 1. For example, if N equal to 6, then what I get? 6 times 5 times 4 times 3 times 2 times 1. This is the definition. So this is equal to 30. This is equal to 24. Okay, so that is equal to 720. Now factorial 5 equal to what? Factorial 5 equal to 5 times 4 times 3 times 2 times 1, which is equal to 120. 120. Okay. This is the definition of factorial. Now another question is factorial 0 equal to 1, factorial 1 equal to 1, factorial 2 equal to 2, factorial 3 equal to 6, factorial 4 equal to 4 times 3 times 2, 24, and factorial 5 equal to 5 times 4 times 3 times 2 equal to 120. So this will go like this way. Factorial 0, factorial 1, factorial 2, factorial 3, factorial 4, factorial 5. So now the question is why factorial 0 equal to 1 and factorial 1 equal to 1? Why should I take these things? Okay. Now the answer is factorial 0 appear in only two cases. This is the case number 1 and this is the case number 2. Otherwise, factorial 0 never appear in any computational method. Case 1 is when you choose all from all from all. This is the scenario. All from all means what? There is a all from all. So now let me explain what is all from what all from all. This is the scenario. Suppose there are 5 balls. From these 5 balls, you are choosing all of them. Okay, you are choosing all of them. 5 choose 5. So that is factorial 5. 5 minus 5. Okay, 5 minus 5. 5 minus 5 equal to 0. So that means factorial 0, factorial 5, and factorial 5 equal to 120. Now, how can I get 120 from the 5 balls, right? So this is the ball 1, ball 2, ball 3, ball 4, ball 5. Okay, this is the one way. Now I want to do it ball 1, ball 2, ball 3, ball 4, ball 5, ball. Okay, now again ball 1, ball 2, ball 4, ball 3, and then ball 5. This is the way if you arrange 5 balls. So this is one arrangement. This way I can get 5 of the balls. That is the another way. This is the another way, and it will continue. This is the first way, second way, third way, and this is the 120th way, which is equal to I can get 5th ball, I can get 4th, I can get 3rd ball, I can get second ball, I can get first ball. This is the way you can get. So in such a case, in order to get all of these, number 120 to obtain mathematically, and this is visualizations, you have to consider that factorial 0 equal to 1. Otherwise these computations will not work. Other than factorial 0 equal to 1, if any other number you will put, you will not get 120, which we are getting by this visualization. In a small example, if you ask me, take a look at that. Cat is a 3-letter word, right? Cat is there. I am choosing all 3 letters from the, I'm choosing all 3 letters from the 3 letter. 3 permute 3 permute 3 equal to factorial 3 and 3 minus 3. Okay, 3 minus 3. Now factorial 3 equal to 6, factorial 0. 0 equal to 1 and 6. So now I get here 6. Now write in here CAT cat, CTA ACT, ATC, and TAC and TCA. Okay, so this is the 6 OS. This is the 6 OS we can get by visualizations, and this is the mathematical way we can get this 6. Visualizing 120 of these combinations of 5 balls is possible, but it will be time consuming, but mathematically we can obtain it. Now I have shown you that two scenarios factorial 0 appear. One is when you choose all from all, which I have shown you. All the 5 balls are chosen from the given 5 balls, and this is all 3 letters that I have chosen from the 3 letter of the word cat. Now I want to consider the second, which is choose nothing from all. Here, all from all, then I can write here nothing from all. That means nothing I can choose, right? Nothing from all. From all. Now I want to give you a new example, nothing from all. Suppose I have a 5 pen. Pen. PE and pen. I have a 5 pen. How? This is my first pen. Okay. This is my first pen. Okay. And that is my second pen. This is my second pen. Okay. And this is my third pen. This is my third pen, yellow. And that is my fourth pen, which is equal to blue. And this is my uh, fifth pen, which is equal to black. Okay, now I want to come in here. I say two scenario, two cases. Now from the 5 pen, I do not want to choose anything. Okay, I don't want to choose anything. If I do not want to choose anything, suppose I want to use here combination formula, instead of which I'm going to discuss what is combinations. But instead of P, let me put here C. C, I do not want to choose any. I choose 0. 0. The for the combination is 5. Choose X, which could be written as factorial and factorial X, and the 5 minus X factorial. This is what the formula. So now if I want to write here factorial 5 and factorial 0 and 5 minus 0 factorial. Okay. This is what I can write. Now take a look at that. If I do not consider factorial 0 equal to 1, the combination formula will not work. How? Then take a look. If I put here 1, and then if I put here 5, and then if I put here 5, 5 minus 0 equal to 5. So this cancel. So there is a 1. So this is the 1. So that means I am choosing 0. So from this 5 pen, where green stands in the first positions, red in the second, yellow in the third, blue in the fourth, and black in the fifth. If I do not choose any pen, if I do not remove them, if I do not shift them, if I do not move them, these 5 pen can stand there in this format forever, where green pen stands first position, red pen in the second positions, yellow in the third, blue in the fourth, and black in the fifth. Okay, so this is the visualizations that 5 pen can stands in their format forever if I do not choose any of them. So this is the visualizations why factorial 0 equal to 1, that consideration. If factorial 0 equal to 1 are not considered, then generalizations of permutations and combinations for any scenarios will not work. New computational methods need to be discovered, which has not been discovered in past 2000 years. So this is the rationale why factorial 0 equal to 1 and factorial 1 equal to 1. There is a worldwide agreement that factorial 0 should be 1, otherwise the permutation combination formula for the for choosing all from all or choosing nothing from all, these two scenarios, permutation and combination formula, will not work. Okay, so this is what the basic explanations of why factorial 0 equal to 1. Now I want to demonstrate another problem. As I say, you see a cat, right? Cat is a word that consists of three letters. Now I want to choose any two letter. How many ways the letters, if the question, if I pose the question, how many ways, the letters of the word cat can be arranged if two letters are selected or chosen. Two letters are selected or chosen. Okay. So 3 permute 2. Take a look. 3 permute 2 factorial 3 and 3 minus 2 factorial, which is giving us factorial 3 divided by factorial 1. So factorial 3 equal to 6. So that is the answer. Now let us check CA, AC, and then CT, TC, and then AT, TA. So this is the visualizations and this is the mathematical formula. So order matters. Which positions are occupied by what, that matters. So you understand that when order matters, by reading the questions, by reading the problem, you have to decide whether it is a permutation problem or combination problem. Now I want to discuss same problem by using combination technique. Okay. Now come here, combination formula, combination. Order does not matter. Order does not matter. Order does not matter. What does this mean? This means order does not matter means, suppose there is a three letter word CAT, cat. Okay. CAT cat, it doesn't matter whether you have written is CAT cat or you have written CTA or you have written TAC or you have written TCA or you have written ATC or you have written ACT. Okay, doesn't matter how. So that means only one is enough. So in such cases, 3 choose 3. 3 choose 3 means factorial 3. And then see, I put here C. And permutation, I put P. Factorial 3 and 3 minus 3. So 3 minus 3 equal to, this is factorial 3. 3 minus factorial 0 and factorial 3. This cancel this. So I have all the way 1. Okay, so the formula for combinations is the formula for the combination is n cx, which is written as factorial n and factorial x and factorial n minus x. Okay, and minus x. And this is the formula for the combinations, and this is the formula for the permutation. Factorial n minus x. This is the formula for the permutations. This is permutations, permutation, and that is combination, combination. permutation and combinations. Okay. Now I want to give you another small scale problem. How many ways? How many? Um, how many ways? How many ways the letters of the word cat be arranged by choosing two letters and order does not matter. Does not matter. So two letter, right? So two letter we want to do. So cat has three letter. Three, choose two. Take a look at the formula. Factorial 3, factorial 2, 3 minus 2 factorial, which could be written as factorial 3, factorial 2, factorial 1. Then it should be written as 3, 2, 1. And then it is written as 2, 1, 1. So I have just 3. Okay. Now I want to show you what are those 3. So CA1, CT distinct, and then A, T. So these are all distinct. So in such a cases, you can rephrase the problem. So rephrase the problem. The previous problem that I wrote purposely in this format, I can rewrite this problem. I can rewrite this problem in a little bit different way. Take a look at that. How many distinct, how many distinct, how many distinct word, how many distinct, how many distinct letter combination, how many distinct letter combinations could be possible when two letters are selected from the word cat. See, how many distinct letter combination could be possible when two letters are selected from the word cat? Now, by reading the question, anyone will understand that this is a combination problem. Okay. So you have understand what? You have understand after this lecture, you have understand BPC, which known as basic principles of counting. You have understand why factorial 0 equal to 1 and why I have provided you the rationale, and then what is permutation and what is combinations. This core idea you have understand by reading, by watching this video. Okay.